Okay, for the next lesson in how to use oscilloscopes and other test equipment, we're going to be talking about function generators. So sometimes you need to create a specific type of signal so you can inject that in your circuit, see if your circuit's working well or how it behaves. We talked about the oscilloscope and how we can measure time-varying voltage signals and how useful that is. And we use some sensors to generate voltage signals that we measured, digital and analog. Now we're going to look at how you can use a function generator to generate those signals, and we'll use the oscilloscope to record what those signals look like and just talk about the different options. Okay, so here we have our oscilloscope at the bottom of the screen, which we've been using in the previous lessons, and at the top of the screen we have the function generator. And so this is a really useful tool that will let you generate different types of signals. And like I said, we can inject those into a circuit and we can see how the circuit behaves. Or we can, in this case, we're just going to go directly to the oscilloscope, and basically whatever comes out of the function generator will be what we see on the oscilloscope. So it should be really straightforward. We're not going to use the scope probe for this lesson, so we can remove this. You can just rotate that and pull it out. Just rotate this and pull it out. What we're going to use instead is a BNC cable. This lets you go directly from the output of the function generator to the input of the scope. So I'm going to connect it to, this one has 2 channels. I'm just going to connect it to channel 1. And then I'm going to connect the other side of it to channel 1 of the scope. Okay? All right. So for right now, I'm going to hit the auto setup button, which shouldn't really display anything, but we have 1 channel visible. We have the cursors here, which we'll use later. And now I'm going to go to the function generator. So the first thing that's up here is a sine wave. So what I can do is look at the parameters of that sine wave that we have set up. So here we have frequency, 1 kilohertz. We have amplitude, which is the voltage from Okay, so now that I have the function generator connected to the oscilloscope, we can take a look at what these signals look like as they're coming out of the function generator. So we're going to look at the first one here, which is a sine wave, and we can look at the properties that we have set up on the function generator. Here it says frequency, 1 kilohertz, amplitude, which is the voltage from the bottom of the sine wave to the top. This says 4 volts. The PP stands for peak to peak, so 4 volts peak to peak. And the offset is where the center of this sine wave is in relation to 0 volts. So if I move this up, it'll move the sine wave up. If I set it negative, it'll move the sine wave down. Okay? And let me just quickly go through and do that. Amplitude, offset, I can change this number and you can see it moves the reference point. The last one is phase, which is where the signal starts in the x scale with relation to time being 0. So I can change that one as well. And you can see it shifts the signal. We discuss phase in terms of degrees, 360 degrees being 1 full period of the wave. But we're not going to mess with those right now. So we're just going to leave everything as is. We're going to press this button to turn the output on. Okay? And without having to do anything, I get the sine wave on the oscilloscope. If it doesn't show up, this should be something the scope should easily be able to figure out. Just hit the auto setup button, and it should be able to detect that wave and scale it appropriately so you can measure it. So if we go and verify some of these numbers here, we'll use the cursors. Let's start with Y. We'll put 1 at the top. We'll press this button to move the bottom one to the bottom of the wave, and we have 4 volts. So that's good. We're going to look at the X, press this button, and now we'll start basically, let's just pick the top of this sine wave, and we'll move the other one to the end of that period, the start of the next one, and we have 1 millisecond, which corresponds to basically 1 kilohertz. And as you see up here, it's 1 kilohertz. Now, just to show that this changes what you see on the scope, let's go and change some of these values. So let's change the frequency. So I'm going to change it to 2 kilohertz. Okay, that doubled. 3 kilohertz, 4 kilohertz. So this is changing the output of what comes out of the function generator. If I change the amplitude, I can change this voltage. Now it's 5 volts, 6 volts. Okay, now let me just make it 1 volt, and let me change this offset. So I'm going to change this offset by half a volt. And I can use these arrows to move which decimal point I'm going to change. So I'm going to move it to half a volt, 500 millivolts. And now you see this shifted up half a volt. And instead of being centered around 0 volts, let me go back down to 0 here. Oh, it's going to make me... Okay, so now it's centered around 0 volts. If I, again, I'll move it up to half a volt. Okay, now you see the bottom of the sine wave is at 0 volts, denoted by the yellow triangle, which is where your 0 volts is for channel 1. Now you might ask, why is it scrolling across the screen? It was nice and stable before. So this has to do with something called the trigger. And when we have periodic waves, things that we're measuring, signals that we're measuring, anything that's periodic, it's not that helpful to look at it like this when it's moving constantly. So all these scopes have something called a trigger circuit, which is on the right side here. And we can use this to freeze the image of the signal based on whatever parameters we define. So the easiest thing is if we hit single, it'll just capture 1 screen's worth of data. But we have to let it trigger. So the reason it's not triggering is this bottom knob is called the trigger level. And like I said, the triangle on the left is where your 0 is for channel 1. But this right triangle is where it's going to trigger. So right now it's set to 0 volts. And since the signal just basically gets almost down to 0 volts and doesn't cross that line anymore, it's not triggering. When we had this going below 0 volts, it was triggering on that. So if I move this offset again, see, now triggered because this line goes below 0 volts. Let me move this up back to half a volt and hit single again. And again, it's just sitting there, not triggering. So what we can do is we can move this level up a little bit. Okay, now it triggers at something above 0 volts where this triangle is, and it captures the waveform. So that's 1 screen worth. If you look up here, it says stop. It's red now, so that means it's not capturing. It just captured 1 screen worth and it stopped. If I hit run again, it'll capture another, it'll capture continuously now. And this changed to auto instead of single. Move this so you can see it. So this is in auto mode. So now this is continuously capturing the waveform. So if I change it, you'll see it change. Okay. If I press single and it just captures 1 waveform, 1 screen, this changes to red. If I move this, it doesn't change anything on the oscilloscope screen because it's not capturing any more data and showing it on the screen. It's just showing you that 1 single screen worth of data that you captured. Okay. For the most part, you can let this run and you can leave this on auto. And as long as you get your level set correctly, you can get a pretty stable signal that's easy to look at. Okay, so that is a sine wave. Let's look at some of the other types of waves here. So we can look at waveforms, and we get a bunch of different options. Square waves, okay? And again, we can change a bunch of parameters related to the square waves. I'm going to talk about one here that's new that we'll get to when we talk about motor control. It's called duty cycle, and that's in percentage. So if I go down to that, watch what happens as I increase this. It becomes asymmetric. Right? The top part of the square wave gets fatter, and the bottom part gets thinner. And if I go below 50%, the opposite is true. The bottom part gets fatter, and the top part gets thinner. That's going to be super useful later, so just kind of keep that in the back of your mind. But for right now, we'll set this to 50%. And half the time it's low, half the time it's high, and it's square wave. Okay, let's look. So the final mode we're going to talk about is burst mode. And this is useful when you need to send a signal to enable something every once in a while, or maybe just one time, just to turn something on, test an on-off switch in your circuit. And so the way we're going to set this up, I'm going to set up a square wave that is sending a short pulse every 1 second. And so what I want to do here is, first thing I want is to go to this pulse feature. And so this is basically a square wave with a long delay. We're going to say, instead of frequency here, we're going to go to period, so we can define it in time. I'm going to say I want this every second, 1 second. Okay, so every second we're going to get one pulse. Now I want it to be a 5-volt signal, so we'll go to amplitude. I'll say 5 volts peak to peak. And then I want it to start at 0 volts, and I want it to go to 5 volts. Not the way it is right now, where it starts at negative 2.5 volts and goes to positive 2.5 volts. So that means my offset has to be 2.5 volts. And when I press this, watch what happens to this green line. It moves down to the bottom of this pulse. Okay? And then, let's see, do we need anything else? So we're going to enable the output, and let's see what this looks like. And so let me zoom in here. Let's try auto. Okay, just finding something. Let's set this to something more reasonable, like 2 volts. Let's move it up to the middle of the screen. And now it's a little hard to find the signal, so what I'm going to do, this level set to a decent value, but let's just press this roll button and see what comes up. So now we can see there's little spikes every second apart, okay? But I want to trigger on that so I can look at it closer up. So first, let me make sure my trigger level is good. So we're going to set it to right around there. And I'm going to say normal. And I'm going to zoom in quite a bit. And then I'm going to see if I caught that. There it is. So that's the square wave pulse. It is one of these divisions, as you saw, was 200 microseconds. 200 microseconds. And if we look up here, the pulse width is 200 microseconds. And if I zoom way out, to 1 second per division, we can see each one of these ticks is 1 second apart. So that's how I would generate a short pulse, 200 microsecond pulse every 1 second that starts at 0 volts, goes to 5 volts, and back down to 0 volts.